Have you ever wondered why you don't just float away into space while walking to school? Or why your shoelaces stay tied when you pull them tight? Or why a skateboard eventually slows down, even on a smooth floor? All of that happens because of invisible helpers working behind the scenes, forces. Today, we're going to meet 4 of these helpful forces: friction, gravity, tension, and the normal force. Let's see how they make everyday life possible. Let's start with friction. Friction is a contact force that tries to slow things down when they slide or try to move across a surface. Think of it as the invisible hand that says, "Whoa there, not so fast." Ever tried sliding on a carpet versus a smooth wooden floor? Carpet = high friction. Wood = low friction. Without friction, you couldn't walk, you'd just slip around, cars couldn't stop, pencils wouldn't work. Friction between the pencil and paper lets you write. Friction can be useful, like helping your shoes grip the ground, or annoying, like when it makes bike tires harder to pedal. But either way, it's always working to resist motion. Next up, gravity, the one force you've felt since the day you were born. Gravity is a non-contact force. It pulls objects toward each other, especially toward the center of the Earth. That's why when you drop your phone, it falls down, not up. And why the moon stays in orbit around Earth. On Earth, gravity pulls everything downward, toward the ground. The cool part? Gravity doesn't just affect heavy things. A feather and a bowling ball both fall at the same speed in a vacuum. No air, no friction. So gravity isn't just about weight. It's about mass and distance. And it's the reason you're not floating in the air right now. Thanks, gravity. Now meet tension, the force of pulling. Tension happens when something like a rope, string, wire, or chain is pulled tight. Think tug of war. When you and your friend pull on opposite ends of a rope, the rope becomes tense. Tension is the force that's passed through that stretched object. It keeps bridges suspended, zip lines strong, your shoelaces tied, elevators from falling. The tighter the pull, the more tension there is. But if the tension becomes too much, snap! That's when things break. So tension is like the invisible line of communication between 2 pulling forces. And finally, the normal force. Sounds boring, right? But the normal force is anything but boring. It's what keeps you from falling through the floor. The normal force is the upward force that a surface pushes up with to support your weight. Let's say you're sitting on a chair. Gravity is pulling you down. But the chair, it's pushing up, perfectly balanced. That push-up force from the chair, that's the normal force. You don't float because of gravity, and you don't sink thanks to the normal force. It keeps your feet on the floor, your books on your desk, and your cereal bowl safely on the table. Let's put it all together with a real-life example. You're standing on a sidewalk, holding a dog leash while your pup tries to chase a squirrel. Gravity is pulling you and your dog down toward Earth. The normal force from the ground is pushing you both up so you don't sink. Your shoes create friction with the ground to keep you from slipping, and the tension in the leash is the pull between you and your very excited dog. Boom! All 4 forces in one moment, real life, real science. So why does any of this matter? Because these forces help us design buildings and bridges, build sports equipment, launch rockets, create roller coasters, and just walk safely on the street. Understanding these forces helps us solve problems, build smart, and predict motion, from skateboards to spaceships. Here's your forces challenge for today. Look around your house or school and find one place where friction is helping, one thing that tension is holding up, one object being pulled down by gravity, one surface pushing up with a normal force. Draw a quick sketch or just make a list, and share your examples in the comments. And don't forget to like, subscribe, and tap that notification bell. Because next time we're talking about balanced and unbalanced forces, and how they can make objects stay still, speed up, or tumble over. Until then, keep observing the world around you, because forces are always at work, even if you can't see them.